Hello friends, let us now learn some important points about the X-ray beam restrictors, collimators. Collimator is the best all-round X-ray beam restrictor. It has two advantages. It provides an infinite variety of rectangular X-ray fields. Then second, the light beam shows the center and exact configuration of the X-ray field. So in this collimator, there are two sets of shutters. Here you can see that there are two sets of shutters which control the beam dimension. So this is shutter 1 and shutter 2. Both these will control the beam dimension, and these two shutters will move together as a unit, so that this second shutter, so these move together as a unit, so this second shutter will align with the first to clean up the penumbra. So the penumbra which is created by the first shutter is cleaned by the second shutter. So this is actually made up of two shutters. So this shutter, so the second shutter will cleanse the penumbra which is produced from the first shutter. Then this shutter functions has two adjustable aperture diaphragms. Each shutter will contain 4 lead plates. Each shutter will contain 4 lead plates, and these plates move independent with each other. Each shutter have 4 lead plates, and the 4 lead plates will move independently in pairs. So when they move independent in pairs, one pair can be adjusted without moving the other pair. So this functions has the two adjustable aperture diaphragms. So one lead plate can be moved independently of that other. So one pair can be adjusted without moving the other pair. So as a result, this permits movement of infinite variety of squares and rectangles. This is one type, this is one type. So this will permits an infinite variety of square and rectangular fields. So this independent mechanism will permit infinite number of square and rectangular fields. So when all the shutters are closed, all of them will meet at the center. So if it is closed, then all of them will meet at the center and no X-ray can transmit through this shutter mechanism. So the advantages is it can have infinite number variety of squares and rectangular field sizes can be produced. So if you see, this is the X-ray beam. Okay, this is the X-ray target, X-ray beam. So this is the filter. Then this is a glass mirror. Okay, the distance between the X-ray tube and mirror is important. So the distance between the X-ray tube mirror and the bulb will be equal. So this light bulb will produce light rays, and these light rays which are produced are reflected by the mirror, and they align along the X-ray field. So this is the shutter mechanism, that is collimators. All of them are aligned inside the collimator. So this is the X-ray beam, this is the light beam, this is the shutters. So if you see, the X-ray is illuminated by the light beam in the light bulb in the collimator. So the light beam is deflected by the mirror which is mounted at 45 degrees. The target of the X-ray tube and the light bulb should be exactly the target of X-ray tube and the light X-ray target and the light bulb should be exactly same distance from the center of the mirror. So as the light beam passes through the second shutter opening, it is collimated to collide with the X-ray beam. The distance from the mirror to the collimator, the distance from the mirror in the collimator to the X-ray target is very critical. The collimator must be mounted so that the X-ray target and the light bulb are exactly the same distance from the mirror. If so, this collimator will helps in identification of the center of the X-ray field. So if this collimator is mounted too far from the X-ray target, the X-ray source will be farther from the second shutter than the light source, thus the X-ray beam is smaller than the light beam. This collimator helps in identification of center of the X-ray field. This is accomplished by painting a cross line on the thin plexiglass mounted on the end of the collimator. A thin plexiglass is mounted on the end of collimator. On this thin plexiglass, a cross line is drawn indicating the center of the X-ray field. The light beam that illuminates the radiographic field also shows the center. Collimators, if like have some backup system for identification of the field size in case the light bulb is burnt out. So the backup system is present for identification of the field size. The X-ray field size for various target film distances is indicated by calibrated scale on the front of the collimator. So these calibrated scale will help us for identifying the center of the X-ray field. Today, non-mobile radiographic equipments in United States, with a few special exceptions, must be equipped with automatic collimators. These automatic collimators are called positive beam limiting devices. Automatic collimators are the same as other collimators, except that the shutters of automatic collimators are motor driven. When a cassette is loaded into a film holder or bucket tray, sensors which are present in the tray will identify the size and alignment of the cassette. The sensors will identify the size and alignment of the cassette. These sensors relay the information to the collimator motors. These sensors will relay the information to these collimator motors. So these send the information to the collimator motors, which position the shutters exactly to match the size of the film being produced. So this is positioned in such a way that these shutters will match the size of the film being produced. A perfectly aligned collimator will leave unexposed borders on either side, on all the sides of the developed beam. A perfectly aligned collimator will leave some unexposed borders on all sides of the developing film. Then, these positive beam limiting devices must be accurate to within 2% of source to image distance. It is required that total malalignment of the edges of the light field with respect to the edges of the X-ray field along the length or width should not be greater than 2% of the distance from the focal spot. The malalignment of edges should not be greater than 2% from the distance to 2% of distance from the focal spot of the X-ray tube. The malalignment of edges of the light field and the X-ray field should not be more than 2% of distance from the focal spot of X-ray tube to the center of the field. So thus this is important for alignment adjustment. If there is any problem in alignment of mirror, or if the light source is not aligned properly to the X-ray beam, in all these cases the X-ray beam is not properly aligned with the light. So all these will result in malalignment, and because of malalignment the image is not properly formed. So our aim is to test the X-ray beam and the light beam alignment. So testing of X-ray beam and light beam alignment. Alignment of this X-ray beam and the light beam should be checked periodically because the mirror tends to get out of adjustment from daily use. The only equipment needed to test the alignment is 4 L-shaped wires of 14 to 17 inch X-ray film So they require, for the only equipment needed to test alignment includes 4 L-shaped wires, a 14 to 17-inch X-ray film in the cassette, and a small lead letter R. Place the First, place the film on the X-ray table. So this is film placed on the X-ray table. Then open the collimator shuttle. So this is the collimator shuttle is opened to an appropriate size. This is collimator shuttle which is open to a convenient size. This is the light bulb. This is the light adjustment. So first collimator shuttle is open to convenient size, which is for 10 to 10 inches. Size of 10 to 10 inches. And the film is around 14 to 17 inches. Now position the carefully L-shaped wires. L-shaped wires are positioned at the corner of the light field. So this is the light field. So L-shaped wires are positioned corner of the light field, and R is placed in the lower right corner. So position the L-shaped wires at the corner of the light field and R at right lower corner. Now then make an X-ray exposure. 40 inches field, 3.3 milliampere second and 40 kVp to mark the position of X-ray field on the film. Now, without touching the film or wires, enlarge the field size to 12 to 12 inches. So now you will have to take one more exposure. So before that you will increase the field size to 12 to 12 inches. So this is the and then expose the film for the second time with the same exposure factors. First, a test film taken in the collimator is shown here, whose mirror is out of adjustment. The L-shaped wires indicate the light beam, whereas the X-ray is black, indicating the darkness of the X-ray. So here the dark center which is present here shows the position of the X-ray beam, whereas the wires indicate the position of the light beam. So this is out of phase. So R letter assists in orienting the film properly. Now with the help of this R letter, adjust the mirror and then repeat to test the alignment again. Now adjust the mirror and again repeat to test the alignment again. So to adjust a mal-aligned mirror, return the processed X-ray film to its original position of the X-ray table. R in the lower right corner assists in orienting the film properly, and position the light beam to the image of the wires as you did earlier for the film exposure, and then adjust the mirror in the collimator until the light beam coincides with the X-ray beam, and repeat the test to make sure that the mirror adjustment has correctly aligned the light and X-ray beams. So these are the important points about collimators. Thank you.